In Lecture 8A, we will define random samples and obtain one if given a population of data, define and identify biased sampling methods, and distinguish between random samples and the more common research samples. To perform a simple random sample, you have to use a table of random digits. A common misconception that some people have is that techniques such as drawing a number out of a hat are random techniques. They really aren't. In fact, my favorite example of how you gain an advantage in a lotto-type drawing is from when I was on a flight to Las Vegas a few years ago. The Frontier flight crew announced that they were going to have a lotto drawing. To participate, you needed to place your seat number on a $1 bill and put it into a bag. The bill, drawn by the cute kid in the front of the plane, will determine the lucky winner of all of the bills put in the bag. Well, I got my bill out and I wrote my seat number on it, but then I stalled. I stalled because I wanted my bill to enter the bag towards the end of the collection. Additionally, I kind of crumpled the bill a little bit to add texture. My husband claimed it would never work, but sure enough, the kiddo drew out my bill and I won $78. Cool, huh? A much less fortunate example of sampling gone wrong occurred in the 1970 draft lottery. In an attempt to expose male youth fairly to the risk of being drafted, a lottery was held to allocate birth dates at random. 366 capsules, each containing a unique day of the year, were successively drawn from a container. The first date, September 14th, was assigned rank 1. The second date drawn was April 24th. It was assigned rank 2, and so on. Those eligible for the draft who were born on September 14th were called first for physicals. Then those born on April 24th were tapped, and so on. This lottery was a source of considerable discussion before being held on December 1st, 1969. Soon afterwards, however, a pattern of unfairness in the results led to further publicity. Turns out that those with birth dates later in the year seemed to have more than their share of low lottery numbers and hence were more likely to be drafted. On January 4th, 1970, the New York Times even ran a long article. Statisticians charged draft lottery was not random. The article described the way the lottery was carried out, and with hindsight, one can see how the attempt at randomization broke down. The capsules were put into the bin month by month, January through December, and subsequent mixing efforts were insufficient to overcome the sequencing. Sampling is fundamental to statistics because we use samples and information about samples to make predictions about populations. Unfortunately, we never actually know if we were right. So it's one of the necessary evils. To use a sample, you have to agree to accept some uncertainty about the results. So, how can you truly obtain a random sample? Well, these are the steps to follow when selecting a simple random sample. But rather than dwell on this slide, let's actually apply the steps in an example. In this scenario, doctors identify chronic tension-type headaches as headaches that occur almost daily for 6 months. The question is, can antidepressant medications reduce the number and severity of these headaches? Investigators want to compare 2 treatments, the antidepressant alone and a placebo alone. The headache sufferers named below have agreed to participate in the study. Now, use Table B, starting at line 20 and reading horizontally left to right, to randomly assign the subjects to treatments. As Spatz instructs, we can start anywhere on the table and read in any direction. In this sample, though, I've asked you to start on row 20 and read left to right, simply so that we can all end up with the same result. In future assignments, I'll dictate how you select your sample as well, so we can use the same key to compare our answers. In practice, however, you could set your own starting location and direction. As long as you use the table correctly, Your resulting sample should be random. Begin by assigning sequential numbers to each of the subjects. I've numbered them from 1 to 36 alphabetically for our convenience. It's okay that the list is first sorted alphabetically, because the table of random digits should ensure a truly random selection is achieved. Next, find line 20 and read in 2-digit sequences, because the total number of subjects was 36, which has 2 digits. When the number is valid, that is, when it is from 1 through 36 and hasn't already been selected, mark the participant. Continue finding valid numbers until half the participants have been chosen. These 18 participants will be in the antidepressant alone group. The remaining 18 will be in the placebo group. So let's start this one together, and then I'll flip to the completed selection. Reading line 20 in 2-digit sequences yields the following numbers: 75, 88, 41, 29. 29 is a valid number. It's between 1 and 36 and hasn't been already used. Keep on going. 52, 84, 31. Mark it. 89, 51, 08. Mark it. 72, 30, 56, 46, 20. Mark 20. 91, 31. 31's a repeat. 88, 98, 72, 45, 37, 58, 54, 36. Mark 36. Thus, reading line 20 resulted in 6 participants being selected. Numbers 29, 31, 08, 30, 20, and 36. Continue to line 21. By the way, if we had a number left over on line 20, then it would have looped. It would have taken that last number and then the first number from the next line. So starting 21 is 16, mark, 77, 73, 71, 16, repeat. 58, 55, 04, mark. 29, repeat. 58, 21, mark. 46, 04, repeat. 39, 10, repeat. 01, mark. 17, mark. 58, 78, 94, 81, 37, 81, 06, mark, and 20, repeat. Line 21 resulted in 6 additional participants being selected. They were 16, 04, 21, 01, 17, and 06. You keep going on like this, going on to the next number, and next line, and if necessary, the next page, until 18 total unique names are selected. And here is that selection. Thus, the experimental group chosen would consist of all of the yellow highlighted participants. The remaining 18 participants would comprise the placebo group. Spatz uses the Literary Digest voter survey for 1936 to discuss the perils of biased samples. I'd like to elaborate a bit on his example. So if you haven't had a chance to read page 151 yet in your text, go ahead and pause the video and go back and take a quick look at that, then resume. There were 2 basic causes of the Literary Digest's downfall that year: selection bias and non-response bias. The first major problem with the poll was in the selection process for the names on the mailing list, which were taken from telephone directories, club membership lists, and lists of the magazine's subscribers. Such a list is guaranteed to be slanted towards middle and upper class voters, and by default to exclude lower income voters. One must remember that in 1936, telephones were much more of a luxury than they are today. Further, at a time when there were still 9 million people unemployed, the names of a significant segment of the population would not show up on the lists of club memberships and magazine subscribers. At least with regard to economic status, the Literary Digest mailing list was far from being representative in a cross-section of the population. This is always a critical problem because voters are generally known to vote their pocketbooks, and it was magnified in the 1936 election when economic issues were preeminent in the minds of voters. This sort of sample bias is called selection bias. The second problem with the Literary Digest poll was that out of the 10 million people whose names were on the original mailing list, only about 2.4 million responded to the survey. Thus, the size of the sample was about 1/4 of what was originally intended. People who respond to surveys are different from people who don't, not only in the obvious way, that is, their attitude towards surveys, but also in more subtle and significant ways. When the response rate is low, as it was in this case, of 0.24, a survey is said to suffer from non-response bias. This is a special type of selection bias where reluctant and non-responsive people are excluded from the sample. Dealing with non-response bias presents its own sets of difficulties. We can't force people to participate in a study, and paying them is hardly ever a solution because it can introduce other forms of bias. There are ways, however, of minimizing non-response bias. For example, the Literary Digest survey was conducted by mail. This approach is most likely to magnify non-response bias because people often considered a mailed questionnaire just another form of junk mail. Of course, considering the size of the mailing list, the Literary Digest really had no other choice. So you might assume that real research is, of course, going to use random sampling, because doesn't that sound like the best possible option? In real research, remember, the goal is to generalize to a population. And realistically, being able to define every member of a population really isn't possible. So real researchers often use convenient samples because it's not practical or it's simply not possible to identify every member of the population or to ethically include them in the research. Why is this okay to do if a random sample is the best option? Well, it's okay because in research there's this standard of expectation to replicate results. What one researcher finds or one group of researchers find is not going to be accepted as truth until it's been replicated over and over and over again with similar results. And even then, there's always the idea that there's going to be some sort of uncertainty in measurement and uncertainty in interpretation. There's going to be some sort of uncertainty. So realistically, real research will use contrived samples, but it is done in such a way that the results at least have uncertainty about them that can be predicted. And that's going to take us into the rest of this chapter where we start talking about sampling distributions of sample means and confidence intervals.